Hi, Christian. Welcome to the podcast, Everyday Metallurgy.
Hi, Peter. Thank you for inviting me for...
Yeah. Christian, today we're going to talk about a subject that is of interest for many people. I brought with me some of these bullets, different sizes. I was on the shooting lane trying to shoot with small, bigger, and big handgun.
Yes.
And I was wondering what's inside these, and when looking around, I found things like these, and this looks very complicated. So I would like to learn more about what is in, what kind of metals are in, and how are they made, and why did they choose that kind of materials for products. Therefore, I reached out to you because I knew you through our mutual society, the Danish Metallurgical Society, where you are representing the Danish defense as metallurgist. But would you give a fly into yourself
Yes.
before I go too deep?
Okay, my name is Christian from Maase. I'm a metallurgist at the Danish Defence Laboratory. And I'm educated as a machine engineer from DTU and have a European welding engineer certificate, and always tried to be a welding engineer. My first job was also a welding engineer, but the problem is that it's not a question of me finding metallurgy. It's metallurgy finding me, because every time something happens, and then it shows that I'm much more worth for the company as a metallurgist than as a welding engineer.
Yeah.
Then I just say fine. I have a lot of courses as a metallurgist in DTU. I made my thesis also in metallurgy, but I tried to escape, but it wasn't possible. Then I'm here working as a metallurgist at the Danish Defence.
Yeah. And
I do the most exciting. My job is the accident board. Planes that fall down. If you see the television, you have that accidents thing.
Yeah.
It's not just like that, because we don't have that kind of accidents, but that kind of job, looking at defects and damage on flying, but also not flying vehicles.
Okay.
And
it could be high impact as well.
Well, yes, we have an accident about flying things that falls down. They are quite damaged by, but it's not the high impact we think when we're talking about bullets, because that is extremely high. It's not just something flying down, falling down and hitting something. It's much more destruction and destructive and follows. We had some things, but those are not disclosable.
That's fair. I promise not to dig too deep in the secrets.
Oh, you can try. I just stop when it's necessary.
Yeah,
no problem.
Thank you, Christian. When we talk metal in bullets, why is that of interest these days?
Well, a bullet is something that is designed to a job. A bullet is also something that has to be made in high quantity, a low price. And it has a niche, and the metals chosen for that bullet is the metals that are best. They have the best properties for precisely that use. We're talking about the bullets you showed. They are copper colored.
Yeah.
It's not copper. It's brass, but it's brass with a very high content of copper. 5 to 20% of zinc.
Yeah, these.
No. These are 70-30. It was the picture you showed.
The picture.
The bullet color on the. They are very red and dark. Why is that? It's because when you shoot with a rifle, you have the bearing. The bearing have a rifling inside that accelerates the bullet, making it spin. And the wears have to be low. It has to be a self-lubricating material. It has to be hard enough to not fragment on the shooting. And has to keep things clean. Lead is very dirty. It gets that oily surface when it gets sold and rust corroded. And is very soft when you shoot with it. And then the first riflings of the turns of the rifling will shave the surface of the lead and making it dirty. And clogging the gun if you shoot a lot with it. Then everything has a job. And we choose, the producer says they choose the best material for that job.
But now you mentioned lead, and when you look in old movies, it's always I'll fill you up with lead. Or silver if it's a vampire. But what is the history of bullets? When did it start? When were the first guns made, or the first rifles? And what was the material used for bullets at that time?
Well, we have been throwing things at each other since we got arms. But when we're talking about bullets, we're talking about normally firearms. And what I have been looking at the Google, and that has been at the early the Chinese making fire lenses, bamboo tubes, but they fill it with black powder and flints and shrapnel from bronze production, and particles or projectiles that aren't well defined as a bullet, but it was something they threw at somebody with a lot of fire and smoke. They're the first examples. If we go to later on, 1400s, you have cast lead. Made as spheres, bullet, round bullets. And you load it at hand with powder, cotton, a lead ball, another cotton thing, pressing everything together, not too much because it could explode, and then fire it. They were smooth in the barrel. It was just a pipe. No rifling, nothing. And in the 1830s, they started making the bullets more cylindrical. Sorry. And they started making it more not just precisely the form we have today, but more like that, keeping a better aerodynamics. But you need to get the rifling to get a stable bullet.
Otherwise it rotates.
Because if you don't rotate, it rotates like that. Doing a lot of drag and losing a lot of velocity.
So it will go away and not straight.
Yes.
Yeah.
When you arrive at the late 1800s, then we have the metallic cartridges, shells, but you have the bullet on it, meaning that you have one piece you put on the gun and you shoot it.
Yeah.
Making it faster to load a gun and less accidents by hitting the powder together with the pipe.
Yeah, good
a
idea.
lot of bad things happen with that.
Yeah.
And then they started also making the full metal jacket.
Yeah, what is that?
Full metal jacket is the red cover you have, the brass cover you have on the bullet.
Yeah.
Then you have, I have a picture I can put on, that one.
Yeah.
And then you have this is the metal jacket.
Yeah.
That envelopes the whole bullet.
What is that made of?
They're made of copper with 5 to 20% aluminum, zinc, sorry.
Okay.
And you have here a little bit of air is not necessary. It's not, they don't have a function on it. This is steel core and this is lead.
And why this combination of different metals?
Shall we talk about that a little bit later?
Okay.
Because it's, you gave me a list of a way to walk.
Yeah.
And if we take that, we are making a shortcut.
That's perfect.
Yes. Yeah. In the First World War and Second World War, they were it is a period where you had the highest evolution on the technologies about weaponry. That's not natural. And was there where they created the calibers we use today, 5.56 and 7.62 millimeter. Is the most used calibers now. And they start making specialized bullets too, like hollow points, armor piercing, tracers, and so on. And now we have today where we are doing a more precision engineering, where we are using computer-aided design to not much changing the bullet, but making the production more effective. When you produce bullets, you're not producing thousands, you're producing millions.
Yeah.
If you look at the statistics from the Second World War, where they just went and emptied the weapons like that, they didn't hit anybody.
No.
Very few bullets hit somebody.
Yeah.
A lot of people died, and you can imagine how the quantity of bullets they used in the war.
Yeah.
And long-range sniping is also an issue. Not an issue, but is a point where we are creating new technologies, new weapons, or new bullets too.
Yeah. So what is next generation? I remember I saw many years ago a presentation of a guy, I think he was from Finland. He was telling that first he started having a job developing next generation bullets. But then after that, he changed job and developed a bulletproof vest that could resist the bullet he just invented. And then after that, he went back and made a new bullet that could penetrate that vest. So he went back and forth.
Yes.
Where are we today on the development of bullets and bulletproof equipment?
A very good question.
Yeah.
But as I said before, the bullets have their functions, and they are made specific for a specific use. The bullet we saw before, that is a steel core, and shall I put it up again? You see here that we have the full metal jacket here, and we have a lead core behind. The lead is there because lead is a very good ballistic material. It has a high thermic resistance. It's ductile, but it's not as other materials that would disintegrate on impact. It keeps its form more or less.
Okay, it doesn't splat.
It doesn't splat as much. Of course, if you shoot it at a armor plate, then it splats. The steel does it too. But if it hits a person, it won't splat. It will deform and make a lot of damage. But it will keep more or less the form. The steel is there to make this bullet a hard bullet. If you had 100% lead, then it would be called a soft bullet.
Okay.
And you could have 100% steel. It will be a harder bullet, but you have the risk of ricochet. Hitting something hard. Then you can put it sintered copper powder. Is your alley. And that will be a bullet that disintegrates on contact. And that is one of the points. This bullet is an attack bullet. Meaning, if you shoot at somebody, the bullet hits, you have a customer. It comes to you with a knife in his hand. And you have a weapon and you shoot him. If it's a bullet like that, it goes through the customer but he doesn't necessarily stop. He continues attacking you. That means that bullet is not thought as a defense bullet, a defense ammunition. If it was a soft one, or better, hollow point with a hole here in the front, that makes when it hits the target, it opens up and delivers more energy to the target. Then the shock wave is so high that the target will fall down.
You'll be blown back over.
No, not necessarily, but it wouldn't be happy.
Okay.
It will, I mean, you put a lot of damage on it, and there are law enforcement are often interested in when they shoot a target, shoot only that target. If you have a bullet that goes through persons, then you will hit somebody you don't want to hit. That makes the necessity of a bullet that delivers the energy to the target, but not more than that. And there are some bullets where they have polymer point. Is more 9 millimeters, the round-headed bullet, where they have a very high deformation on impact, delivering a lot of energy, and doing that. But often also bullets that are machined from brass. You have with a long hollow, and you have some fragmentation grooves, so they can open on impact. And there are a lot of types of bullets, and the materials have to be chosen accordingly to what you want them to do.
Yeah. And lead, is it only there because it has the mechanical property, the softness, and the ductility, or is it also the weight of it that is of interest?
Yes, the weight is a very important feature, and it's also that the question: shall we find something that works like lead, but is not as dangerous environmentally as lead? And there are bismuth can be used. It has a density of 0.85% of lead.
Okay.
Giving a good ballistic properties too, but is too expensive because you don't mine bismuth. Bismuth is mined as a byproduct when you mine silver, tungstenium, and so on. And mostly of it is from China. And there's some in Mexico. So it's they use it, but it's not as much as people want. For hobby use, they will have to use something else than lead.
Yeah. And so for hunters, it's bismuth today mainly. Yeah,
but you can use steel.
Yeah,
but still destroy your weapon. Still have a high wear on your rifling.
Okay, that's why you make the full metal jacket to protect your rifling.
Yes. Precisely.
Yeah.
We can say about you have also tracers. Tracers are bullets that have a little bit of phosphor or some other pyrotechnical element behind the bullet, and when you shoot it, then it react with air or ignites, and you can follow it at night. When you start, you can see where you are shooting.
Yeah.
A jet fighter with a machine cannon, shooting 100 shots a second, have one of those tracers for every 100, 200 shots.
Okay. Yeah.
So the pilot can follow where he's shooting and try to hit what he wants, because you don't have the same feeling when you're on an airplane of direction.
No. Yeah, so, I could imagine. Yeah, but it is more expensive. I could imagine.
Well, specialized ammunition is a little bit more expensive. It's more expensive than non-specialized, but still, if you need it, is okay. The problem is making millions of bullets like that.
Yeah.
With bismuth in all this volume here, it will be quite the expense in relation to lead.
Okay.
Lead doesn't cost anything.
Yeah. If we look at it, put it like that, what can you tell a little about the physics from when you start to ignite it and on the way out through the rifle and during flight? What acceleration, what velocities, what energy level are we talking about? Because when you shoot, you have is it called recoil? That it's
recoil,
it goes back. But if you have energy balance, the weight it pulls back should be the same weight or the same amount of energy that it has at impact, or is it not equal?
Yes, energy doesn't are not created or disappear. It's constant, and the recoil you get is the energy leaving your gun is the same.
Yeah.
When you ignite, you have a pressure build up in your chamber, sending the bullet through the barrel, and that the powder doesn't ignite at once. It builds up rapidly, but it takes some time to ignite completely, and then it hits the barrel and the rifling, and the bullets start running. And you can feel the pistol dry.
It's turning.
It's turning in your hand.
Yeah.
No.
Yeah, I didn't know that.
No. Well.
Yeah. So what speed are we talking about?
It depends a lot in what are you shooting with. If you are shooting with a handgun, a 9mm, handgun, then it's about 300, 400 meter per second. Is just over supersonic.
Yeah.
And if you are shooting with the 5.56 caliber rifle, you are about 900 meters per second.
Okay, a lot more.
A lot more, but there are systems shooting faster than that, but they're not normal. They are specialized weapons. But if we take, I have that kind of data. I don't remember.
Yeah.
If we take a 9mm, 370 meter per second, energy is 530 joules. Do you remember that?
Yeah.
If we take 5.56, is 920 meter per second, and size 1700 joules.
Wow, a lot more.
A lot more.
Yeah.
If we take the 7.62, is about 900. The velocity is more or less the same.
Yeah.
But energy. Oh, sorry. One too many. 830
joules.
Velocity. But joules,
okay.
3,200.
Wow.
Is about twice as much as the 5.52.
Yeah.
If you take 7.62, is a really hard punch you get from it.
Yeah. If we take that and put that energy into a bulletproof vest, it can absorb it. How does it work? What does it do to the bullet since it doesn't penetrate?
What happens is, I have another picture.
Yeah.
Unfortunately, I didn't took the picture with just one shot. It will be easier to explain. But imagine that this wall goes here with just this hole.
Yeah.
Then this is a clay wall. That clay has almost the same resistance, elasticity of the human body. Okay.
Yeah.
Then this is a clay of the same clay, formed as the back of the ballistic plate we used here. Ballistic plates are plates you put on a vest. Then you have one in the front, one in the back.
Yeah.
Yeah. This is shot with a soft bullet, and the ballistic plate is formed like a very hard front made of bore carbide, 4 millimeters in thickness, 5 millimeter thickness.
Mm-hmm.
That is very hard, and when the bullet hits it, the bullet tends to fragment, and that's the job of the core. Behind it, there is a layer of about 15 millimeters of polyethylene fibers. They are compressed together,
Mm-hmm.
and their function is to stop fragmentation, the fragments.
Okay.
But with saying that the polyethylene deforms, it makes that what we call backface deformation of the ballistic plate. And is that what we see here in the clay? Is the backface deformation of a bullet that consists of 100% lead. These are 7.62 bullets. If we took a hard bullet with a steel front, that hole would be narrower, about 1/3 narrower in diameter, but this is 23 millimeters deep deformation. But it would be about 40 in depth. It's not, you don't walk out of it.
No.
This is the ballistic plate is a level 3 ballistic plate. It's made to precisely that ammunition we tested here. But we could have a level 4 ballistic plate. Is heavier, chunkier. That would be better to stop a bullet like that. But it's is always the problem. You can protect yourself, but you cannot move after having so much plates on you. Then there's not the meaning on it.
Yeah, so it's you cannot you are really hurt after being shot still, but it doesn't penetrate.
Yeah, but you have to see that the first thing is the function of the plate is not to, like in the films, you can stand up again and fight. At the same time. This is for you to survive 24 hours. Then you can reach a hospital. Your friends can take you to a hospital and you can be treated. But it's not for fun. If you see a plate with a 40 millimeters hole in it, and can imagine is a thorax there.
Yeah,
that's difficult.
Yeah, absolutely. Yeah, I understand. Then I would also like to talk about some special bullets. I remember when there was the war in Iraq, there were a lot of talking about soldiers that have been affected by radioactive uranium. And then they said, but we didn't shoot with anything radioactive, no nuclear, but uranium was there at the tip of the bullets, as I understood it. Is that right?
Well, I'm a bit cynic.
Yeah.
Uranium is a very dense material. It's the same density as wolfram, tungstenium. And it has the characteristic that when it breaks like glass, pointy and sharp. Then if you shoot at an armored car with a grenade with depleted uranium on it, then because of the density, and you have this property that it breaks and sharp and is cuts through things and very hard too. And then it's very good to go through armor plates. And when you go through armor plates, it's like having knives around, going around in the air and cutting people in pieces. But that, and it's not handguns. You're not using a normal small bullet. You're using bullets from a machine cannon, maybe 25 millimeters, 35 millimeters.
Yeah, okay.
They are bigger, like something like that. But tungsten is expensive. You can say, okay, uranium is expensive, but no, because when you get uranium out of the earth, you have to do it out the ground, you have to refine it, because it's not all uranium you can use in nuclear reactors. Then you take the good uranium, 238, I think, and you have the rest. That is most of the rest when you take it from the ground.
Yeah, there are only a few percentage of
what you do with it is waste. Is radioactive waste. Then if you have to throw it away, it costs a lot of money.
Yeah.
But if you shoot it, it's free. That's my version, and I personally stand by it. Can be at other military people will say that that's not like that.
But tungsten, could it do the same?
Yes.
Is it also fragile, and will that be able to make the same cutting in the armor?
No, it density-wise is the same, and you can use it in the same way, but it's not as effective as depleted uranium. Uranium is better to do that job than tungsten.
Yeah. Okay.
But if you tungstenium, they used on that bullet I showed you before, precisely to go through the ballistic plate, because tungstenium doesn't deform or fragment. Then you have the pressure point of all energy of your shot placed in a very narrow point. And it goes through. It's not, I don't have a picture. I wouldn't be allowed to show it. I had it, but I have a picture with a plate like that I showed before, with such a hole going inside. And it's when the bullet go through the plate.
Okay.
It doesn't make the same deflection of the energy. They just point the energy when one place and just make a hole.
So a concentrated energy point.
Yes.
Yeah.
That's because we used the wrong ammunition to test a plate.
Yeah.
Happens.
Okay. Then some of the issues that are very modern to talk about now is environmental impact, and you have mentioned it a little, talking about lead is not so good to put out in the nature, so therefore it changed to bismuth. But is that an argument today when making bullets? Are people really talking about it, or is it just effectiveness, high productivity, high impact?
At the moment is the second. The military is not talking about finding solutions for the lead. That's because the main interest is buy.
Yeah.
And you have to just produce the bullets as fast as you can, and the environmental question comes later on. But there are, of course, also those that are trying to find another alloy instead of bismuth that can do the same job as lead with the same advantages without the drawbacks bismuth had. There are bullets they are using, I said before, sintered copper as instead of lead. It's a little bit lighter. You have the advantage because you know that the energy of the bullet is the weight combined with the velocity. A light bullet will give higher velocity, but lower
energy.
Let's say it's the same energy, but when you shoot, the friction with air have a lot to say in your accuracy and your range. And the kinetic energy is not as dependent of the it depends of the weight, yes, but the kinetic velocity is more affected by air friction. Meaning a light bullet won't fly as far as a heavy bullet with the same energy to start with.
Okay. I forgot when you had your picture up there and you had the jacket and the steel part and the lead. How are they manufactured, these parts? Is it machine parts? Is it casted? Used to powder metallurgy could be used as the copper if it was that. And how is the metal jacket built upon it?
It is the other way around. You make a jacket from a coin. You press it. It's a little bit bigger. Then you put the rod of steel that have this form more or less inside, and then you put your lead inside as a rod too. Then you have a swagging. You have a press making pressure on the outside of the bullet. Pressing everything together, and then you have a pressing the from behind, creating a pressure inside. And that gives the process that gives the best accuracy on the dimensions from the outside. Precisely here you have a press with that makes an indentation. You can see it here. And the bullet glides on the rifling the barrel from these 2 points. Here and here.
Okay.
But this is the points where you have the biggest diameter. And in the indentation, the cartridge holds on the bullet. Meaning the cartridge stays here like that.
And the steel itself, how is that manufactured?
These rods, they are pressed.
And
they come as a rod and they cut in.
It's not machined out.
It's not machined, no, it's pressed. This is made of very mild steel.
Okay.
It's not hardened.
And the lead, is that casted parts or is that machined or pressed out as well?
It's pressed. And what is funny is that I have some examples where you have some lead here in the end too.
Mm-hmm.
There are two possibilities. The pressure is so high that you have lead being pressed inside here.
Wow.
Because I checked it. They don't. They said they don't use heat to. They not molten lead. They're not using it. They're using fast lead.
Yeah.
But in that production, there are a lot of heat created.
Yeah. Yeah. So it could eventually melt some of the lead and bring it to the front.
Yes.
Wow.
But I believe that is but if you have other bullets that are made by machining, especially brass.
Okay.
Where they can make very advanced designs on the bullet. Because they try to reduce the drag from the air friction, and giving a better aerodynamics for the bullet. Example, yes. You're not in Denmark and most of Europe you're not allowed to have hollow points, a hole here. This is against the conventions.
Yeah, because that gave such this opening and a big impact.
Yes, it's very nasty for the people getting hit.
Yeah,
because you are handicapped. They destroy your body, no matter where you hit.
Yeah. Christian, we're about to come to an end.
Okay.
But where is next level? Are we at the peak of bullet development, or is there something in the pipeline that you could share?
We are the top. Yes, of course. No. There are some developments. Some years ago, I was visiting a factory in Switzerland, Rheinmetall, where they made something they call the Millennium Gun. It's a ship-mounted gun, also ground, where they shoot 35 millimeter grenade after missiles and planes and that kind of things. Yes.
Yeah.
And I just take this out.
Yeah.
And that grenade is shot by a revolver, meaning is a barrel, and there is chambers that drive around. I don't remember, it's 4, 5, 6 chambers that drive around and shoots about 1,000 shots a minute. And there is a thing in the end of the barrel, in the muzzle, that programs the bullet to explode after so many milliseconds. And the point is that there is coming a missile, and the computer says you will be here in half a second, then you go there and explode a little bit before. And when it explodes, there is a box full of tungstenium pellets that spread those pellets. There's an explosive that spread the pellets around, but it's rotating. Then it opens like a flower. It's very nice to see the results.
Yeah.
But it makes an area for about 1.2, 1.5 meters effective, and then it's like following a missile and trying to gets those pellets to hit it, and very impressive. And they are talking about putting sensors on bullets, electronic sensors that can detect, and they can, and they are also talking about small mechanism that can guide a bullet and make a better sniper ammunition, or be making ammunition that can change the direction and follow a moving target, for example. It's not now, but you see this machine 3D machining is creating some ideas about making it smaller for adapting in this small ammunition.
Yeah.
At the moment, they are working on bigger ammunition, but the idea is to get down on smaller end weapon level.
Yeah.
But it will never, because it's a question of price, it will never be the mass. It will be the special jobs.
Yeah.
Yes, one is my favorite is polymer cased ammunition. If you think about one of the problems with weaponry and ammunition is that it's heavy. The soldiers have to carry it around. You have to have the pots around, and they are easy to hit. Then the idea is to reduce the weight of what one person can carry, but make this weight more effective. One thing is going down on caliber. You have like we talked before, 5.5 and 7.6 millimeters. The one is what's more energy, but it's very much heavier.
Yeah. So that's
and the weapon,
something like this.
Yes, the difference. But it's also make the weapon also more heavier, because you have to deal with higher pressures and higher energies. Then you reduce the caliber, you reduce the weight of your weapons, and you can reduce by making your cartridges lighter or making the cartridge free. For example, if you do your cartridge out of material that burns when you shoot it, then you don't have anything you have to shoot out. They can be cheaper to manufacture, and they can also be lighter to carry. You don't have so much problems with cartridges around, empty cartridges around.
And they are made in polymers or
nitrocellulose.
Yeah.
Nitrocellulose is just burn is what we use as powder today. Is what also called smoke-free powder. Old days you used black powder. When you shot, a lot of smoke around. You could see anything. And Nobel created the process to make nitrocellulose that is then used everywhere for that. They talk about small caliber rounds for snipers with small wings, and some devices that can guide. They are an idea of making a hole in the front of the bullet and some escape routes, 4 of them. And you have a valve that opens and closes the escape routes. Then you can, like, not much, but a little bit, enough to guide after.
I see, yeah.
I'm not involved in that that studies. I'm more, when things go wrong, I have to find out why.
Yeah, that's fair. Christian, thank you very much. This was a very new field for me, so I learned a lot today. Thank you. And thank you for your willingness to share. If people are really interested in this, do you have a recommendation where they could look for more information? Wonderful. Thank you.
This is one of the producers. This, what I showed you, is a catalog with the bullets they produce, handgun catalog.
Yeah.
And they have a lot of funny information about velocities and all those tables and what kind of bullets they are in use today and what they want to be in used in the future, because they want to sell it. So.
Fantastic. Wonderful.
Yes.
Thank you very much.
Oh, thank you. It was fun.
Yeah. See you soon.
Yeah.
Bye.
Goodbye.
Wow. Did you know that this is going on the development on bullets? I learned a lot. And I would like to end this telling that I got the inspiration for this episode during the summer when I joined a concert with one of my favorite bands called Bullet for My Valentine. So if you, by some accident, is getting inspired by a band or something you see, and you would like an episode on that, please reach out to me. I would love to make it. I would like to invite you, or I will find a top expert who can tell more about it. So please help me join the community, subscribe to the YouTube channel, and we will learn together. This is wisdom worth sharing.